Welcome to 9.2, everybody. In 9.2, we're going to talk about a z-score in a standard normal distribution. Now, a standard normal distribution is a normal distribution. It's just got a couple special properties. And what the z-score, we're going to find out, is related to is sort of goes back to the empirical rule, where it talks about the number of standard deviations you are from the mean. Because remember, the number of standard deviations has a corresponding area under the curve, which is probability and a percentage of a population. Okay, so what I've done for your notes here, and you're going to want to pause and write some of this stuff down, especially when it comes to formulas and things like that. You're going to need them. So 9.2, I've got the title here for you, and specifically what a z-score is, it's a number that indicates how many standard deviations you are from the mean. And remember, that directly corresponds to an area. When a z-score is positive, the data value is above the mean. That means you're to the right of the mean. And when it's negative, you're below the mean, which means you're to the left. When it's 0, it's equal to the mean. All right, so these are just some basic rules that I've highlighted here for you to write down and take a look at. And right here's the formula for finding a z-score. All right, so a z-score formula says, hey, take a data value, x, subtract the mean from it, and divide by the standard deviation. Remember, standard deviation is on average how far each data point is from the mean. So if you think about this, if you take your data point and you subtract the mean from it, that tells you how far you are, right? Then you're going to divide by the average distance. That's going to tell you how many standard deviations you are from the mean. Okay, so that's what a z-score is, literally. Now, I feel like there's a who cares aspect to this when you just saw me, if you watched the video where I did everything with the normal CDF and the calculator. And what happens here, back in the day, when I learned all this stuff, this is coming up in the next video, we had to look this stuff up in the back of the book in tables. Right, you would have to compute a z-score, go back there and look, and it would give you these areas under the curve. It's not as important as it used to be. I don't think it is, but there's still questions we run into that we would need this formula, and here's one of them right here. So we're going to do a couple of these, and we'll just let this go. Okay. All right. So one question that could be asked that has to do with this formula would be something like example 1 here. It says the mean number of total miles ran last week by each member on a track team was 4. So that's your mu with a standard deviation of 1.2. It says if Clay's z-score was 2.5, how many miles did he run? Now that would be talking about, look, I'm solving for x. So I'm going to go ahead and just stick this in here and write down what we know, okay? And that's the very first thing you want to do with these problems. So we know we're going to use that z-score formula because the problem involved the notion of a z-score. It even says z-score. You know you're going to need that formula. So we know right away here. Let me move my picture out of the way. Oh, come on over here. If I can get you out of the way. I have to do a little bit of both. Move this a little bit too. Okay, so we know that z was equal to what? 2.5. And we know that mu, or the mean, was equal to 4. And we do know the standard deviation. What was that? 1.2. So we're going to plug this into our formula. We're going to write 2.5 is equal to, we don't know how many miles you ran, minus 4 divided by 1.2. All right, so we're going to solve this for x, which means we want 2.5 times 1.2, and that's equal to x minus 4, right? And we need to add 4 to this thing here. So 2.5 times 1.2 plus 4, and that's our x value. And I find, you can check me on this, that x is 7. So that's an example of doing one of these problems. I do want to do one more with you real quick, so I don't want to waste a lot of time here. I want to make this one video. Let's go look at one more. And I think we'll just do the second one right here. We won't do 3 of them. All right, it says a set of test papers is normally distributed with a standard deviation of 5. If Riley scored at 83 with a z-score of negative 0.4, what was the mean? Here we go with the z-score written into the problem again. We know we're going to need that formula, and that's how we would spot this one. So we're told that Riley had a z-score of negative 0.4. What else do we know? We know that the standard deviation was 5. And we know that, well, I gotta read it again. If he scored an 83, we want to know what the mean is. So we're solving for mu in this case. All right, got it. So we know x is actually 83, right? All right, so we're going to solve for the mean. So we're going to have negative 0.4 equals 83 minus mu all over 5, right? So we're going to have negative 0.4 times 5, and that's equal to 83 minus mu. And all right, so what are we going to get here? So I got negative 0.4 times 5, which gives me negative 2, and that's 83 minus mu. I need to subtract this 83 over, so I get negative mu is negative 85, so it looks like mu is going to be mu's equal to 85. And that's how you would solve one of those problems. The next video, I'm going to get into more calculator work, and that's probably what you're going to really want to pay attention to the most. Just throwing these couple problems out there in case you run into them. So anyway, see you next time. Watch the next videos. Don't skip these videos.